the Foodlog, our effort to building a multimedia food recording tool, and also we'd like to share some the observation we have had in the observing when observing the food recording data. And at the beginning, already this morning Ed already energetically mentioned, the food is an emerging topic for information technology, and food is related to many things. At the beginning, we didn't imagine the food has such a big field, but the food is really a big area because the food is related to many things, such as the nutrition and cooking recipes and healthcare diet, and interaction and marketing and agriculture, etc. The problem is that for IT people, the problem is how we can support them by information technology. Now, I'm pretty much interested in the healthcare issues, and then for healthcare issues, the big thing is the obesity. Obesity leads to many diseases, and this is an article I found several years ago. And obesity became a bigger crisis than hunger, and almost all countries except a few African countries, the obesity becomes a big crisis. And this is a very recent article I found in Scientific American in the last August. And it claims that the world is entering a new era of severe obesity, and humans grow heavier. Why it says is that the infographics is pretty interesting. Let me explain a little bit. The horizontal axis shows the growth rate before 2000, BMI growth rate before 2000. The vertical axis shows the BMI growth rate after 2000. And each point has corresponds to a country, either men or women. The men is shown as squares, and women are shown by circles. As you can see that in this region, all the countries, except these several countries, have a BMI growth rate is positive. That means that we are getting heavier, right? And the world average is here. Then a man is a little bit, is in this region, which is the accelerating region. And then the women is on a line. That means the BMI growth rate is the same. And then looking at this, U.S. is, here. And then it's not, among the population, the U.S. is not the worst. It's just somewhere in the middle. But it's nearly twice as much as the world average. Well, now we can read many interesting things. By the way, Canada is doing good. And somehow Japan, the women, the only women are getting the thinner. And the healthcare technology, the status of healthcare technology is I would like to talk about the status of the healthcare technology. In order to monitor our health, we need three things: and then the energy consumption, and the vital signs, and the energy intake. And from the technology point of view, the energy consumption is almost in our hand. It is in our hand that we can have a wearable and wear it all 24 hours a day. But for vital signs, we have home appliances we can measure easily. But the most difficult thing is the food intake. Because of many reasons, the food has a lot of variation. That is the reason. Well, there are the smartphone appeared, and most are the text input, the type text, and then we have a food journaling. That is the conventional food recording tool by using the smartphone apps. And we have made photo-based recording tools. At the beginning, we made a web-based food diary, and then later we made a smartphone-based food diary. They are made publicly available since 2009 and 2013. Well, let me just briefly introduce this our Foodlog app. At the beginning, well, this is the first version launched in 2013. Well, it has, in addition to text search, we had a visual search, which is only limited to personal data. And we also had a free text input. And then these are the screenshots. And then, well, sorry, this is Japanese. You cannot read, but this is a name of the food, and amount, volume, and the calories. And they are finally recording for each picture. And this app, we published a paper not in the technology, well, not in the computer science paper, computer science journal, but in medical journal. And I'd like to show the very recent one. It has new functions. It has a food and non-food image detection and food recognition. We very rely on deep learning technology. And it also still has a visual search, and it has associative search as well. And let me show a demo. I think if the connection is not good, then I will show the video. Let's see. Okay, and then this is, then it starts, it's immediately search my food picture in my album. And then it shows the food picture. And then I can label it, choose the food domain, and then go to the image recognition. And this is the recognition results. And then the rice is correct, then I can choose this rice. And the amount is probably, this is okay. The volume is difficult to estimate, so that we ask user to do. And then, for example, this one, let's see. Yeah, this is the miso soup is correct. Oh, that's perfect. And then, yeah.
What are these numbers?
Oh, this is the energy, kilocalories. And this is a chicken fry, and then this is correct. So this is a very good case. And then, well, this is a cabbage. Well, how do we say in English? Well, I don't know, but this is correct. But assume this is wrong, then we initiate associative search. Then, well, assume this is the most close to the candidate, and then take then they initiate the associative search. Then the associative search the food items, which is the closest to in terms of the names and nutritions and whatever. Well, we took the several factors, and then here is another candidates. We can see another candidates based on the associative search. Then this is correct. Then it's done. Then let's see. We have one more remaining. I don't know this. Oh, this is pretty good. So this is that if we push next and then it search the next the food. Well, this is how our Foodlog works, and then the current our Foodlog works, and then that this let's see why it doesn't work. Now this is, I already told you that it has basically, well, it has two components, image-based assistance and text-based search system. And then we used we made public this system, and it has been used by many the general people, and we also produced different applications based on our system by requested, because we are requested to make to produce by some companies. Now we actually made a startup company named Foodlog, and they are in charge of the maintaining the database and producing applications. Then the university are happy in developing new things, developing new algorithms or new things, and and observing the data. Yeah, related works. Well, very recently, this is is Edo's work, and then that is mainly for the research purposes. But two very similar systems are appearing. Well, I'm not sure. This is the Japanese version, and it has also image recognition functions, and it has a very close category. But it can automatically detect the location of the food. Then after they apply the image recognition, then get this type of the picture, and then it is labeled by cause categories. And then from here, then user has to go to a finer levels. And this is something that I got to know from Ramesh, and then US, it's in the public, right? Yes. Then they have food recognition and functions, and then for this given picture, they returns the food items. Well, I tried to do it from Japan, but it's not downloadable. Well, we have collaborated with the university hospital, and they are very much who are working on diabetes and diseases. And then the university hospital are making a system by which they collect vital signs, exercise, and food data, and then based on the recording data, they want to automatically return some feedback to the patients. And now actually they are getting, and in this food component, we have a collaboration. And this is a very recent the screenshots of their system. Well, you can see that it looks like the Foodlog system, but it has, but we show the more detail of the nutrition stored in the database. Then let's go to the observation. We have, by this 3-year operation, we have collected more than 4 million food records, and which contains amazingly the 150,000 unique food names. And well, that's because we allow users to create food name by the free text input. Then they produce lots of names, and I will talk about it later. I come to know that food is very open world. It's not small data set does not work in this domain. And the observation we had from is that it has a very high interclass diversity, very high interclass similarity, and the new classes are generated continuously, and the large personal bias. The people have a very specific tendencies, and this is object size. Well, has some generic nature. I will talk it later. And well, I will show some data, statistics, but the data are sampled at different time instances. So that the T1 means time T1, but I'm not sure when it was. So then so that I just label it T1. And different statistics are labeled T2 and T3, so that the data are not completely the same. But the largest one includes the smallest one, smaller one. For the T1, probably 1.5 years later or less, 1.5 years. Well, I'm not sure, but in this case, we had a default of approximately 1,800 classes. It is our default data, default name of the generic Japanese food. And the user used it, and then 1 million records are in this class. On the other hand, surprisingly, the user generated much more larger class. The 97,000 classes, 50 times larger than the default class are generated by users. And but it contains the 400,000 records. And in total, we had, at this time instances, we had about approximately 100,000 classes. Then let's look at the distribution. Then it's a very steep power of law. Now you can see that this is the frequency. We put in a frequency order. Then the horizontal is a food class, and 1 to 100,000. And then you can see that the most frequent one appears very frequently, but it gets smaller and smaller. And then the more than less than 40,000 appears more than twice. This part, approximately 60,000, appears only once. So it's very, very big data. It has a very, very big data nature. And then let's look at this data. I show 3 group of pictures. Now, what do you understand what I want to say? That this is a yogurt now of content, and this is a yogurt of package, and this is again the package, well, different the package, and this is a yogurt, but the banana chip, banana slice is on its top. Now, this is a different user from a different user. But this user tended to take a picture like this, and this user tended to take a picture like this, so that it's a custom is very different. So that then, although it's a yogurt, but look, the visual appearance are significantly different depending on users. We try to recognize yogurt as a yogurt, but within the class, it has a very high diversity. Then, well, this is another one. Well, this is curry. Ramesh, can you distinguish between the 3?
Actually, in some of those cases.
Yeah. Well, these are the curry, all are the curry, but they're the pork curry and a beef curry and chicken curry, and they have a different name, or different labels. Yeah.
You can have, I don't know how many different.
Yeah, these are topping, right? And then, so that then there is, well, just looking at the picture, the 3 classes, well, are not distinguishable, but actually they are. We want to make it separate, so that then that cause another problems. Then we have to deal with. Well, I do not tell you our one of the solutions that we are considering, but I just tell you the problem. And then here is another interesting observation of the data. This is the new classes generated every day. And it's a little longer the data from the beginning, the 2013 to the recent 16 sometime before we update the system. And then you can see that the number of the new class generated is shown blue, and then red is a ratio compared to the entire data. Now, very interestingly, this red line is very stable, and approximately 4% of the classes are generated continuously. So currently the deep learning work on if they have a big data, but what happens if they do not have a big data? That the new classes are such a bad data. New classes are continuously generated. Then look at more closely the data. Then here is this is our first observation we made for the first 1 million record. Foodlog data is something like this, and then when we had 1 million data after 1 year operation, we had 70K unique names, and then it had a huge variations. So that then we did something to normalize the names. We normalize the names by producing the representative names. Then here is the results, and then this is the average for entire user. The large character means that it appears more frequently than, well, it's Japanese, but you can see that the rice, bread, and yogurt, and soup, and miso soup, and salad, and vegetables will appear. So that, well, probably it is, well, the average people. But look at this data for individual data. Then this is the one of the 6 weeks data of user A. In this case, this user has a very different tendencies. And well, this person has eaten ice cream almost every meal, and then another one. Well, what else is the rice ball or rice or sandwich? Then well, you can see that it's quite far from the average. And then the person is even worse than the largest one is a cookie. Then, well, this is a kind of Japanese cookie that I showed at the picture. And then the second largest a sandwich, like a fruit stand and a lettuce ham stand. So that looking at the label, we know that how the people are different, or how the people spend something, well, unhealthy life. Well, we discuss about this data with the medical people, and then they are quite interested in this. They are not, so that according to the doctor, she said that without any additional data, the 6 weeks the data tells us a lot. Then she may need just this. And then finally, I want to tell you one more thing. And then this is one thing that we found in the data. Well, this is a little more general things. Well, we investigated the object's size. The size of object. Size of object is determined by the bounding box surrounding the object. And IRC-VRC 2013 is a famous data set of general object. You can see that the person and dog and well, the everyday picture in this data set. But the Food 101 data set is a data set used in one of the research in food recognition. And they are captured from some internet service. And their picture looks like this. The one dish is focused in a picture, and then sometimes the picture, well, the food size, the picture only takes a part of the dish, but the size is larger than the picture, saturated. But on the other hand, our data looks like this. Well, it can be a different angle, but the food is, well, put on up. Well, in order to take a less picture, the people used this type of picture very often. And what is interesting in this data is this distribution. Now this is the normalized size. Normalized means normalized to the edge of the length of the entire frame. And then this, the general object data, or the food, the experiment data used in the paper, well, they have this kind of distribution. The red and blue are horizontal size and vertical size, respectively. And you see that the general object data, its distribution is almost uniform. Look at this, the food data. Many are in a saturated region, and the rest looks like uniform. But in a Foodlog data, has a very different nature. It looks like this, and it is very well modeled by log normal distribution. And why is that the reason we saw it is in our case, the segmentation process is can be approximated by multiplicative process. I mean that given this type of picture, all that different from the general object, all the objects are on the plane, right? On a table, the plane. And then there are no overlap. Then the segmentation is something like, well, dividing the image into smaller parts. So that this division, assuming this division is happening in uniform, so it's a result is first we divide it here, and then divide it here, and then divide it here. It's a division of the multiple division are repeating in this process. Then so that it's a multiplication of random variables, and then which result in a log normal distribution. Okay, so I will finish very soon. But the current research issues, well, it's that we are thinking about how to deal with this very open data, and the recognitions, well, unknown classes, new classes, personalization, and user behavior. Those are the very serious research issues for us. Thank you very much.